Hello everyone, welcome to my YouTube channel. In today's video I would like to introduce you to the principle of operation of a scale, also called a weightometer. The key components that make up the scale are the load cell, the signal conditioner, the display, and the power supply. Let me start with the easy one. The power supply, its function is to convert AC voltage, which we are getting from the municipality or from the ESCOM supply, from 220 to 24 volts. That is the amount of voltage that the scale needs to operate. So we cannot apply or supply it with full 220 volts. So the power supply is just there for that purpose. And then on the left, we have a display. It's also called the scale terminal. This is the interface. This is where you as a human being can control or change the parameters of the scale. In terms of you can zero the scale, you can tear the scale, you can also use that terminal to calibrate the scale. This scale, this Mettler Toledo scale is a bit advanced in technology, so it's got this Ethernet cable, and that Ethernet cable is connected to my laptop this side. So you can also, instead of using the display I showed on that side, you can also do the zeroing, the calibration, the setting of parameters, everything, changing of dates and time using a normal laptop. You just use that IP address. So depending on the scale that you're going to be working with, the IP address this side is what you insert on that side, and then you just work with it. But I'm not going to go through the laptop setup. I just put it for the display so that you can understand the features that this scale has. Okay, so we've talked about the power supply, we've talked about the display. Now we've got the last two important components, which are the primary components of the scale: the signal conditioner and the load cell. So let's start with the load cell. A load cell is basically a resistive sensing device that will change its resistance depending on the force that is applied on it. If you apply a force or a load on it, its resistance will change, and that resistance can be manipulated using the signal conditioner, and then the values can be used to display the actual mesh. So the change in resistance in a load cell is directly proportional to the change in mesh. So if we say we apply 10 kg, there will be a proportional change in its resistance. And if we add another 10 kilograms and another 10 kilograms, that's what makes it possible or useful for us to manipulate it to measure mesh. We all know scales are used in various places, from kitchen scales, even in industry they are used in vessels to measure how much material is stored in a vessel, or how much material is flowing in a conveyor. So it's very important to understand scales. In some cases you'll find standalone scales. It's a scale that is just there, used to weigh raw materials or weigh final product, finished goods. Okay, so now, like I said, this load cell is a resistive sensing device. If you can see the parameters or the specifications, it's got a sensitivity which tells us how sensitive the load cell is. The impedance, you get a 350 ohm resistor, which is the standard resistance of that load cell, and then the IP rating that tells you in what kind of an environment can you use it. If it's IP66, then it means it can withstand dust, it can withstand water, those kind of things. Okay, so every time we apply a force here, that force changes the resistance. Actually, in basic electronics or basic electrical, a load cell is a strain gauge. So when you put it under pressure or you apply force on it, its resistance will change, and that's what helps us to be able to manipulate it and use it to measure mesh. So this signal conditioner, we've got 7 wires there. They are in pairs. We've got 2 of them, they are called the excitation wires. 2 of them are called the sensing wires. The 2 of them are the signal, and the 7th one is just the shield or the grounding. So as we supply the signal conditioner with 24 volts, then it will send some millivolts or some voltage to the load cell, and then when the load is applied to the load cell will return a signal in a form of millivolts back to the signal conditioner. And then the signal conditioner can take those millivolts and convert them to milliamps, which is a normal or a most common type of a signal that PLCs can read, that other controllers can read. But because it's also advanced, you can also send the same information as a digital value, let's say, because we are using Ethernet there. So you can send that information to my PC using that Ethernet cable. So that's basically the key components that are used in a scale. In some cases, the manufacturer will not give you these items as separate. This and this will be built into one. So you have a display or a weighing terminal that has a built-in signal conditioner. But in this case, they are just separate, but it doesn't make a difference. And it also doesn't matter if it's a different brand. The key components, the primary components that make up the scale will stay the same. So we can calibrate this load cell using a known mesh. In the industry, we've got things called mesh pieces. Those are usually metal weights that are known that, okay, this weight or this mesh piece weighs 10 kg. So we take that mesh piece, we apply it there, and then we calibrate our scale to tell it. When we calibrate it, we are basically teaching it that the amount of weight that is applied is 10 kg. And then we apply maybe another 10 kg, then we tell our scale that that is 20 kg. Once we've given our scale 1 point, 2 points, or 3 points, usually it can manipulate, then it can measure anything in between. Just as an example, we can apply a mesh of, let's say, 0. The first mesh is 0 because we've got nothing applied there. And then let's say we've got 100 kgs. We apply 100 kgs on top of the thing. Then our load cell can measure values between 0 and 100, even outside 100. That is called interpolating in metrology. But I won't dwell much on that. So let me stop here. I hope you learned something from this video, but the main thing that I wanted to show you is that the key components that are used in a scale is the load cell, the signal conditioner, and the display. And those components, every scale that you're gonna meet will have those components. They may be larger, they may be a different brand, they may have different resistance, they may have different specifications, but the principles of scales remain the same regardless of manufacturer and type. I hope this video helps you to have an idea of how a scale works, and please do like the video, do share the video with someone that may find it useful, and subscribe. And you can place a comment, and if maybe you need me to explain one concept a bit further. Thank you for watching until this far. Enjoy the rest of the day of your day. Bye.